Good morning, everyone. So, yesterday we started looking into how to draw a three-dimensional molecule and two-dimensional plane. So, we'll continue with that discussion. So, we started with drawing of this methane using perspective formula, and we drew these diagrams. So, as you might remember, I'll just recollect it. The lines represent those bonds which are on the plane of the board, and solid wedge represent those bonds which are above the plane, and dash wedge represent those bonds that are below the plane of the board. Now let's look at the second example, and that is dichloromethane. This is a solvent that is used in most of the organic reactions. So I have here a model. So if you look at this model, white bars represent your hydrogens attached to the carbon, green bars represent your chlorine that is attached to your carbon. So I'm holding the molecule in such a fashion that these two hydrogen are the bonds which are on the plane of the on the writing plane. Okay, suppose this is the plane of the board, this is my writing plane, and these two CH bonds are on the plane of the board. And if these two hydrogens are on the plane of the board, then that means this chlorine is above the plane and this chlorine is below the plane. So you can easily visualize that this structure that I have written exactly matches with the model that I have and that I am showing you here in this thing. Now let me move further. Now if suppose I want to write it in this fashion, that means these two bonds, if I have to bring on this side, how will I write it? So for that, now it is when it was completely all hydrogen, there was no problem, because anywhere you rotate, you just have to put hydrogen. But here there are two kinds of atoms. One is hydrogen and another is chlorine. So there is a care that you should take. So if I want to write, suppose in this fashion, I have to bring, I'll draw it, bond like this, and there should be one solid wedge, and then there should be a dash. This is what this model exactly did. But now here we have to take care, because I have to keep in mind that when I draw this structure, these should be equal. Okay. For that to happen, when if suppose I put this as hydrogen, then I have to see whether when I bring this bond here, does this particular bond contain hydrogen or some other atom, that we have to see. So if you look at this model, these two hydrogen, this is our first thing, that these two are on the plane of the board. Chlorine is above the plane, this chlorine is below the plane. Now if I have to, this is my hydrogen in this particular way of writing the perspective formula. Now if I somehow rotate this molecule clockwise by an angle of 180 degree, what will happen? This will rotate by 180 degree, and this, nothing is happening here because I am rotating across this axis. This CH bond I am rotating by 180 degree in a clockwise fashion. So when I rotate it by a clockwise fashion, what will happen? This hydrogen is going to come here. Okay, so that means what? The hydrogen has now come here. Okay, now my chlorine is again, because both are chlorine, one on the front and one on the back. So you have your Cl coming like this. Okay, so this is almost perfectly equivalent to this particular one. Now I'm going to write my model in this term. Now how can I do that? So if I want to keep my hydrogens on the vertical bond, this dash bonds are vertical, and these solid wedge in this particular formula that I have written down is kind of horizontal, right? So how do I write this particular thing? Now, if I have to hold this Just wait a second. Okay, so that ball just fell off. So if I want to write now my hydrogens in the vertical fashion, I told you yesterday these two bonds are below the plane and these two bonds are above the plane. So what happens if I want to place my hydrogens behind? What I'll do, I'll hold the molecule something like this. Here there is a chlorine. Just imagine that there is a chlorine here. Okay. So when I place my model something like this, there should be a chlorine coming here, there should be a chlorine coming here, and then you have your two hydrogens which are pointing in the backward direction. I'm showing you like this. So two chlorines are pointing in the front direction, two hydrogens are pointing in the backward direction. So if I hold my molecule like this, then that means these sides is your chlorine, okay, and this side is your hydrogen. Okay, so this particular model is perfectly fine. Now let me go to the second model. In the second model, what I am having is, instead of a chlorine, I have a bromine here. Okay, so one I have replaced now by three different kind of atoms. So blue bond represent your bromine. Okay, so this what I have written down perfectly matches with what I have showing you here. Now you are able to pretty well visualize. Now let me write it in another fashion. That is, so if I write like this, obviously I have to rotate it by 180 degrees. So when I rotate this by 180 degrees, what do you see? The chlorine, which is the green ball, has come on the front side, and the blue ball, that is bromine, would be coming in the back side. So this is my model for the thing. Okay. Now here you have to take care when you draw this particular representation, where the two bonds are behind and the vertical bonds are behind and the horizontal bonds are on the front side. Okay, so for that purpose, how do you do this? Now, if you suppose you want your hydrogens, which are right now on the plane of the writing plane, if you want to be on the back side, how will you do? You will put the molecule in such a fashion that these hydrogens should go on the back of the plane. So suppose this is the plane of the writing plane. If you want to keep this on the back side, you will put something like this, right? You will bring this hydrogens on the back side. So what happens? Your bromine has come on the your right side and your chlorine has come on the left side. So what happens? Your chlorine will come here, your bromine will come here, your hydrogens are on the top. Okay, so when you get your perspective formula in this particular fashion, it is very simple to write the Fischer projection. Fischer projection is nothing but you will write a cross-like symbol at the carbon, and the intersection of this cross is your carbon atom, and you will attach the corresponding substitute. So hydrogen, there is no problem, you can simply write it. But when it comes to chlorine, it would be just HH and ClCl. Now, if you would have written it otherwise, in this case, it won't be a problem because this is not a chiral molecule. However, when there are four different atoms, you will see that if you write it in the other fashion, that means bromine here and Cl here, it will create a problem. I'll discuss the four different kind of atoms in the class live session that we will have today. So after writing this formula, you can directly make the Fischer projection just by putting the cross and putting like this. But you have to bring your perspective formula in this particular fashion. Okay. Once you bring in this particular fashion, only then it will be matching. But mind it, if you write your formula in such a way that the two vertical bonds are in front and the horizontal bonds are behind, then this you cannot write like this. Okay, you cannot directly copy like this. But if you have written the formula so that the vertical bonds are behind and the horizontal bonds are on the front, then you can directly write them as the Fischer projection. So I hope you have understood how to write the perspective and Fischer projection formula. Probably you can ask me all the doubts in the live session, which we are going to have today, and hope it would be interesting and enjoying to learn. Thank you very much for your attention.